So, one of my self-centered students wants you to see how success. No, I'm sorry, she's not really self-centered. She's proud of her work. I'm proud of her work, and I want you to be proud of your successes. Okay? So she showed how to get this solution like this. Okay, Jamila. Yay! Okay. All right. So what we're doing is we're sharing these two electrons. Hydrogen only needs to share one more, so it only needs two. And then I can share this one between carbon and oxygen. Both the carbon and the oxygen at this point only have 7. A double bond makes it 8. So then from there we do the Lewis dot formula. And let's see, I'm going to put carbon like this and put this oxygen, this hydrogen up here. I could put the hydrogen over here. I'm going to put it down here. And since I have a double bond, I got to squeeze 2 sets of electrons, or 2 pairs of electrons between the carbon and the oxygen. And put the 2 lone pairs out here on the oxygen. And there's formaldehyde. Okay? Formaldehyde. Now, so tomorrow you got to bring long balloons and round balloons, and you need to come dressed for lab. Okay? Long balloons and round balloons come dressed for lab. Huh? Pants, long pants, closed-toe shoes. Okay. Now look, listen. Even though, remember what we said about Lewis dot formulas? They are ways of sort of figuring out how many electrons are shared. They don't actually show you the actual shape of the molecule. Okay? Tomorrow, we're going to use balloon models to see how we actually get a shape out of it. So I want to give you a brief introduction, just a brief introduction to something called hybridization. Okay? Now, okay, recall when we were doing the shape of the orbitals in a molecule that you had a lower, say the first primary level only had an s sublevel, and the s sublevel orbital, the only s orbital, was a sphere. Yeah, you can barely see that, which is kind of the point for me. All right. Then, when we got to the second primary level, we had both s and p orbitals. The s orbital, again, is a sphere, but our p orbitals were double balloon shapes. So we had, let's see, let's do this one up here. There's one balloon. There's a balloon that's sort of coming out toward you here. There's a set of balloons. I know I got another color here somewhere. Going like this. And then the other balloon for this blue one is down here. Y'all please stop talking and listen more. And then the other end of this balloon that's coming out toward you is back here. Okay? Now what happens is these outer or valence level orbitals, this pink one here, this green one, blue one, and orange one, those valence level orbitals are the ones that actually go about sharing electrons. But for it to happen, those orbitals have to hybridize. Okay? And hybridization means you're changing its form. Okay? If we take what we're going to do is we're going to take this pink orbital, let's put a nucleus in here first. And instead of having a sphere, the pink orbital is going to be in the shape of a single balloon. This green orbital, this p green orbital here, 2 nodes, are going to hybridize and change into a single balloon. Instead of 2 balloons, we're going to get this. Okay? This orange set, instead of 2 balloons, we're going to get this. Okay? And the blue set, instead of a single balloon, we're going to get that. Andrew, you don't think this is interesting enough or important enough to pay attention? Come on. Up here. Eyes up here. Ears up here. Jose. Sadrell. Yeah, Sadrell, sit up and pay attention, please. Going from the original shape of the orbitals to this shape, this is called hybridization. Okay, we're hybridizing the orbitals so that bonding can take place. Okay? Now, not all the orbitals will hybridize. Sometimes when we're doing double and triple bonding, some of the orbitals retain their original shape and some hybridize. We'll get into that more tomorrow. Got that? But this is what we're going to be looking at with the balloons tomorrow, and then we're going to look at how the resulting hybridized orbitals form molecular shapes. Now, don't pack up yet. We have some practice to do tonight. Yeah, did you write your homework down already?
Oh, Patricia sends it to me every night.
Who does?
Patricia.
Boy, she's awful nice.
No, she just sends me a picture of it. She is nice.
Okay. This is not part of the homework, by the way. I was just using that to explain my confusion about the way some people write their S's.
Is it the homework? No.
This isn't. This is.
What's that thing? Is that water?
Yeah. I was trying to explain how some people's S's in my first period look like more like cups than S's, and that's all I'm doing there. I was having a trouble recognizing S's because they didn't like S's to me. They used to make these ladles out of gourds, and they look very much like that. And you would use them at a well or something to drink the water.